Dear students, welcome to our YouTube channel Chem Origin. This is Dr. Satish, RGUKT, Srikakulam. Students, in the second module video of thermodynamics, we discuss about the topics state of a system, internal energy, thermodynamic process, and most important thing, first law of thermodynamics and its derivation part. And based on the first law of thermodynamics, a few small mathematical or numerical problems we can solve in the present video. So we can start our video session, module 2 of thermodynamics. State of a system. State of a system is defined as the condition where the existence of the system when its macroscopic properties have definite values. When its macroscopic properties have definite values. Whenever for a system, for example, you can take a gas is present in a cylinder. That you can assume it is a cylinder. In this cylinder, gas is present. So this is our system which is under investigation. So a gas containing cylinder has macroscopic properties. Those macroscopic properties have definite values, means particular values. Those are known as a state of a system. So state of a system, how we define, students? The state of a system is defined as the condition of existence of the system whenever its macroscopic properties have definite values. And next definition is state function. What is state function or what is state variable? We can see. This is an example for our system gas. A gas is present in a cylinder. So these macroscopic properties of a system which change with the change in the state of a system are called state variables or state functions. State variables or state functions. The macroscopic properties of a system which change with the change in the state of the system. Suppose if you change the state of a system, these also changed. So those type of parameters are known as a state functions or state variables, because by changing the state of the system, its properties also changed. For explaining this, we can take water as an example. Water is an example for state variable or a state function. So generally in our room temperature, water is a liquid, but at below 0 degrees centigrade at atmospheric pressure, it is in solid state. But between 0 to 100 degrees centigrade, water exists as a liquid, and above 100 degrees centigrade, water is in gaseous state. See, the same chemical present in one time in solid state and liquid state and also in gaseous state, but it change with temperature and pressure. So therefore, in order to define these state variables, generally we used some parameters. Those are the commonly used parameters to define the state variables are temperature. Generally we denoted this temperature with capital T, temperature, and pressure, and volume, V, capital V, and chemical composition. These are the parameters we are using to define the state variables or a state functions. So the variables are functions which are changed with the state of a system. For that case, the exact value cannot be calculated. It is not possible to calculate the exact value. So in that cases, instead of exact value, we are used to calculate the change in its values. So how we calculate this, it's a change in values instead of its exact values. In the coming slide I will explain. So students, it is very important. State variables or state functions means with the change in state of the system, these macroscopic properties are changed. Those are known as a state variables or state functions. For this explaining, at 1 atmospheric pressure, at 1 atmospheric pressure, the water state is changed. One time it is in solid state, one time it is in liquid state, one time it is in gaseous state. Depend upon varying the temperature. So when temperature is varied, the state of the system, here water I am taking as a system, so its state is changed. So as a state variable or state functions, we unable to calculate the exact value. In that cases we are calculating the change in values. So generally used variables for the state used variables for calculating the state variables are temperature, pressure, volume, and chemical composition. It is denoted with small n. Next topic, thermodynamic process. Thermodynamic process. For explaining these different types of thermodynamic process are there. Isothermal process, adiabatic process, isobaric process, isochoric process. So what are these processes? We can see one by one. For explaining these isothermal and adiabatic, isobaric and isochoric process, we can take an example, a gas present in a cylinder. So this is a cylinder, in this gas is present. Let us assume a gas is present in a cylinder. We can assume gas is present in a cylinder. Suppose, what is isothermal process? Isothermal process is a process the temperature of the system remains constant. In isothermal process, temperature of the system remains constant. Other variables such as pressure, volume and chemical composition may vary. Suppose in a cylinder we can take a gas and above to the gas we put a piston. Generally it is a frictionless piston, means frictionless piston. Generally it is known as a frictionless piston. Means frictionless piston. We can easily move in upward direction or downward direction. See, here the piston is moved in upward direction and comes into this position. If you apply pressure or force on this direction, in downward direction, the piston is coming into this side. The piston is coming in this direction. So this is a frictionless piston. We can move easily in upward direction or downward direction. Therefore, in a system, the temperature of the system remains constant. That type of process are known as a isothermal process. Students, this is very, very important, because in our coming concept, we are discussing about this isothermal process, adiabatic process, isobaric process and isochoric process. Based on these definitions, we can explain the concept of Carnot cycle. That Carnot cycle is very simple concept and easiest concept, but it easily understood whenever you can familiar with these definitions of these terms. Isothermal process, the temperature of the system remains constant in a process, but the other variables, pressure, volume and chemical composition, may vary. For example, in this example, the gas is present in a cylinder at temperature T1. Here the gas is expanded. Due to expansion of the gas, the volume of the gas is varied. Due to expansion of the gas, the piston is moved in upward direction. Here, from here to here, volume is changed. And the number of molecules also increased. So initially N1 is there. After expansion, N1 plus N2, number of gas molecules increases, volume increases, but temperature remains constant. Here also it is T1 and here also it is T2. Therefore, in a process, temperature of the system remains constant, but other variables may vary. that is pressure, volume and chemical composition. So this is the isothermal process. Next, isobaric process. Similar to isothermal process, isobaric process is a process of the system. The pressure of the system remains constant. Pressure of the system remains constant. If pressure is constant, at that pressure, if a process takes place, that is known as a isobaric process. For explaining this isobaric concept also, we can take a gas is present in a cylinder, and this cylinder is attached with a frictionless piston. So initially the chemical composition of gas is N1, and after adding N2 molecules, the gas is expanded and its volume is varied and temperature also changed, but pressure remains constant. Here also pressure is P1 and here also pressure is P1. So pressure remains constant for a system. Pressure of a system remains constant. The remaining variables, temperature, volume and chemical composition, may vary. Those types of process are known as a isobaric process. Pressure of a system remains constant. If temperature of a system remains constant, it is known as a isothermal process. Next, isochoric process. In this process, isochoric process, volume of the system remains constant. Remaining variables may vary. So if the volume of the system remains constant, even though other variables are changed, means temperature may change, pressure may vary or chemical composition may vary, but volume remains constant. So students, one more important thing is that if temperature constant means initially T1, after reaction, after the process also T2, means change in temperature delta T is 0. Here in isobaric process, pressure is constant. Therefore, if pressure is constant, change in pressure initially P1, finally P1 minus P1 means 0. Therefore, change in pressure delta P also 0. In isochoric process, volume is constant. Therefore, volume is constant, initially V1, finally V1. Therefore, V1 minus V1 equals to 0. That's why delta V equals to 0. Next, adiabatic process. In adiabatic process, we can take gas is present in a insulated cylinder. This insulated cylinder concept we already discussed in this insulated cylinder. Isolated system. In isolated system, we already know the definition. We discussed in module 1 video. Isolated system in which neither energy nor the matter exchange with the surroundings. Similarly, in that insulated cylinder, we can take our system gas. So in adiabatic process, what happened? Temperature is changed, pressure is changed, volume is changed, but chemical composition is constant. So whenever the chemical composition is constant, delta N equals to 0. So this is known as a adiabatic process. Students, this is very important. Please remember, in adiabatic process, it is in isolated cylinder. Here it is a 2 compartments. This is compartment 1 and it is compartment 2. In these 2 compartments, pressure, temperature, volume may vary, but chemical composition is constant. That's why delta N is 0, because of it is in insulated state. So because of it is insulated, the walls of the cylinder is insulated, neither energy nor the matter of the system exchange with surroundings is not possible. So this is an isolated system. So these are the 4 thermodynamic process: isothermal process, adiabatic process, isobaric process, isochoric process. Very, very important process. Internal energy. Dear students, this is very, very important. This concept is very important. Please concentrate on this. internal energy. Internal energy is always denoted with a capital E, internal energy. In thermodynamics, generally we denoted internal energy with a symbol capital E. Capital E. Capital E is represents the internal energy in thermodynamics. So what is this internal energy? We can see internal energy. Internal energy of a system is that the total energy present in the system is nothing but the internal energy of a system. Dear students, for example, you can take one cylinder. This is your cylinder. This is your cylinder. In this cylinder is attached with a frictionless piston. This cylinder is attached with a frictionless piston. So in this cylinder, gas is present. Gas is present. Initially, its internal energy is E initial, EIN. So suppose the gas is expanded. If the gas is expanded, then the frictionless piston is moved in upward direction. Then the frictionless piston is moved in upward direction. Then what happens? Its internal energy is changed to EF, E final. EF means E final. EIN means E initial. So here also gas is only present in the cylinder. Therefore, this is our system which is present in a cylinder. Gas is our system. So this gaseous system is having different types of energies. So the total energies of the system is known as a internal energy. So the gas present in the cylinder is a system. It has translational energy. It has translational energy, rotational energy, vibrational energy, bonding energy, electronic energy, plus etc. Some other energies are present. So for a system or a substance, students, a substance may also have different types of energies. Substance or a system may have different types of energies. The sum of these different types of energies, these different types of energies present in a system or a substance is nothing but called as a internal energy. Internal energy. It is denoted with a letter E, capital E. Students, already in the module 1 video, we discussed the concept extensive properties. The properties of a system which are depend upon the total material present in the system. Therefore, internal energy is an extensive property. This internal energy is depend upon the total material of the system. Total material present in the system. So, internal energy is an extensive property. And also it is a state property or state variable or state function. In the previous slide we discussed this state function. So with the change in state of the system, the property may vary. Therefore internal energy is a state property. In the previous slide we said water is a liquid at a constant pressure between temperature 0 to 100 degrees centigrade. At 1 atmospheric pressure below 0 degrees centigrade, same water is in solid state. At above 100 degrees centigrade, the same water is in gaseous state. Therefore, the water's internal energy in gaseous state, in liquid state, in solid state, it will vary with the state. Therefore, internal energy is a state function or state variable. It is a state function or state variable. Internal energy is a state variable. That's why it is not possible to calculate the exact internal energy of a system. Hence, it is not possible to calculate the exact value. That's why we can calculate the change in internal value, change in internal energy value. So whenever it is not possible to calculate the exact value, we can calculate the change in its value. Change in its value we can calculate. Therefore, internal energy is a state function. It is not possible to calculate the exact value. That's why we can calculate the change in value means exact internal energy of a system we cannot calculate because it vary with the state of a system. Therefore, we can calculate the change in internal energy. For example, initially the system have internal energy E initial. After some work done, the system's internal energy is E final. In this change in internal energy case, the energy or heat or work is from system to surroundings or from surroundings to system also takes place. Therefore, change in internal energy is final internal energy minus initial internal energy. Or you can take, suppose this is its internal energy is E1, its internal energy is E2. Therefore, change in internal energy also you can write as a, also you can write like this, E2 minus E1. Therefore, change in internal energy, final internal energy minus initial internal energy, or E2 minus E1. In this manner, we can calculate the change in internal energy. Students, please remember, internal energy is an extensive property and it is a state function. And for a cyclic process, delta E value, change in internal energy value 0. Because suppose here in this example, gas is expanded from here to here. So in this case, the piston is come here, and after that again this piston comes to the its initial state or initial position, and again its internal energy value is E1. Therefore, change in internal energy is delta E equals to E1 minus E1, that equals to delta E is 0 for a cyclic process, and delta E value is positive if EF is greater than E initial or E2 is greater than E1, then delta E value is positive. If E2 is less than E1 or E final value is less than En, delta E value is negative. So be familiar with this topic. First law of thermodynamics, students, this is very important topic in our academic point of view. So first law of thermodynamics, there are several types of definitions. Many kinds of definitions are there for first law of thermodynamics. The very popular definition for first law of thermodynamics is this one: energy neither created nor destroyed, but it can be converted from one form to another. So energy cannot be created or destroyed, but it can be converted from one form to another. So can I once I explain in Telugu? Students, శక్తిని మనం సృష్టించలేము, అలాగే నాశనం చేయలేము. కానీ ఒక రూపంలో ఉన్నటువంటి శక్తిని మరొక రూపంలోకి మాత్రం మార్చగలము. మనం ప్రస్తుతం మన జీవితంలో, మన రోజువారీ జీవితంలో మనం ఈ ప్రిన్సిపల్, ఈ సిద్ధాంతాన్ని యూజ్ చేసుకునే రకరకాల ఉపయోగాలు పొందుతున్నాం. సో స్టూడెంట్స్, in our daily life we are getting lot of applications based on this first law of thermodynamics principle only. The best example is electricity. In the electricity actually it is coming from solar radiation, it is coming from thermal energy, it is coming from nuclear energy, it is coming from wind energy. So different form of energy we are converted into electrical energy and we are using in our daily life. Similarly, you can take another example, the train is running on a railway track with the help of electrical energy. So train taking electrical energy, that collected electrical energy is converted into mechanical energy. Due to that mechanical energy, the train engine will run on the railway track. So in this manner, one form of energy is converted into another form. With that conversion principle, we have lot of applications in our daily life. That's why in module 1 video, students, I already told you there is a lot of applications of thermodynamics in chemistry, physics and in engineering. So everywhere this kind of principle we are using. So students, this is very important definition. First law of thermodynamics: energy cannot be created or cannot be destroyed, but we can convert the energy in one form into another. So suppose, for explaining this concept, we can see, we take one example. If you take a gas which is present in a cylinder, this is a cylinder. In this, gas is present. So this is your frictionless piston. So gas is present in this cylinder. Therefore, initially when a system is changed from its initial state to final state, so initially gas is in this situation. To this, if you supply some amount of heat energy, some amount of heat you can supply. Let it be Q. Let it be Q. So Q amount of heat is supplied to the system. Due to supply of Q amount of heat, there will be W amount of work takes place. So before applying Q amount of heat, initially the internal energy of the gas is assumed as a E1. So its initial internal energy is E1. So after applying Q amount of heat and W amount of work takes place, then the here the work done, then the change in internal energy, how it will take place, we can see. So by applying some amount of heat, suppose our frictionless piston is like this. Suppose here gas compression may takes place. Just you can assume, suppose gas compression may or gas expansion may takes place, like that. However, in whichever the kind you can assume. Suppose gas compression may takes place. So compression of gas takes place. So this is your system gas. This is your system gas. So here the internal energy you can assume as a E2. Therefore, here initially the internal energy is changed from E1 to E2. Therefore, by applying Q amount of heat, W amount of work takes place and internal energy is changed from E1 to E2. Here you are applying energy on the system. Therefore, work done on the system. Therefore, the new internal energy E2 is becomes E1 plus Q plus W. E1 plus Q plus W. Therefore, final internal energy E final or E2 equals to E1 plus Q amount of heat given, W amount of work takes place. So E2 equals to E1 plus Q plus W. If we can take this E1 from right side to left hand side, then what will happen? E2 minus E1 equals to Q plus W. We know E2 minus E1 is nothing but delta E. Delta E means change in internal energy is equals to the Q plus W, heat given to the system, and W, work done on the system. Therefore, change in internal energy delta E, change in internal energy delta E, change in internal energy delta E is equals to Q plus W. This is your first law of thermodynamics definition. Change in internal energy is equals to heat given to the system plus work done on the system. So here work is done on the system. Suppose, for example, you can assume like this. Suppose you can assume like this, students. Suppose this is your system present in the cylinder. This is your initial gas cylinders. Internal energy is E1. So after giving Q amount of heat to the system, so if you boil the system, so Q amount of heat is given to the system and the gas is expanded, then what happened? The piston is moved from here to here. So here the internal energy becomes E2. Therefore, here work is done by the gas, work done by the system. Therefore, work done by the system. Here work done by the system. Therefore, internal energy becomes E2 equals to E1 plus Q plus W. And similarly, E2 minus E1 equals to Q plus W. But interesting point is that, students, here work is done by the system. Therefore, W is How it will changes? W is becomes minus W, not plus W. Therefore, change in internal energy delta E is equals to Q minus W in case of work done by the system. If work done on the system, delta E equals to Q plus W. So students, please familiar this word, work done on the system or work done by the system. Based on this condition, we solve the numerical problems. So you can remember students, change in internal energy is equals to Q plus W, work done on the system. Change in internal energy is equals to Q minus W, work done by the system. Based on these conditions, we solve the numerical problems based on first law of thermodynamics. Dear students, you can see some of the numerical problems based on first law of thermodynamics. So just now we learn delta E. According to first law of thermodynamics, change in internal energy, delta E is equals to Q plus W when work is done on the system, or delta E equals to Q minus W when work is done by the system. So in the question we can see how he was given. A system absorbs 470 joules of heat. 470 joules of heat is absorbed by the system and does work equivalent to 200 joules on its surroundings. Calculate the change in internal energy. Okay students, we can solve this problem. So the question is that, so first we can do solution for the given problem. So system absorbs 470 joules of heat. So given Q equals to 470 joules. Next, and does work equivalent to 200 joules. Therefore, given W equals to 200 joules. And the question is that what is change in internal energy? Change in internal energy. So we know that students, change in internal energy is equals to Q plus W if work is done on the system, or if work is done by the system, change in internal energy is equals to Q minus W. Here in the question he clearly mentioned that a system absorbs this much of heat and the work is equal to 200 joules on its surroundings. Means the working clearly mentioned that here work is done by the system. Work is done by the system. Work is done by the system. Therefore, for calculating change in internal energy, the formula is Q minus W. Given Q value is equals to 470 joules minus, and given W work equals to 200 joules. Therefore, 470 minus 200 equals to 270 joules. So this is the change in internal energy. So students, in this manner you can calculate the change in internal energy. According to first law of thermodynamics, we can apply the formula Q minus W. So in the given problem, the change in internal energy is equals to 270 joules. Delta E, change in internal energy is equals to 270 joules. So dear students, I think you are familiar with the first law of thermodynamics. Delta E equals to Q plus or minus W, work done on the system or work done by the system. I am giving you two problems for your practice. So already you know the first law of thermodynamics. According to first law of thermodynamics, delta E formula you know. So here I give you two problems for practice. You can do. If you have any doubt, you can send me a comment on below of this video. I can solve. Okay. So first problem is that a system provides with 50 joules of heat. So given heat is 50 joules and work done on the system is 10 joules. W is 10 joules. What is the change in internal energy? This is very simple problem. I think it is a 1 mark problem. So 1 mark also very more for this problem. And the next problem is that The work done by a system is 8 joules. So W is given in joules. When 40 joules of heat is supplied to it. So Q is 40 joules and W is 8 joules. Calculate the increase in internal energy, or nothing but indirectly he ask again change in internal energy. So students, I hope you enjoy this session. First law of thermodynamics and numerical problems based on that, internal energy, and so those concepts these are very important concepts, students. So if these videos are looking good and very interesting, please share to your friends and your classmates in your institute and other side of the institutes also. Okay, so students, thank you very much.